Hi everyone. So my name is Grigor Fursin. I'll try to speak up. If you don't listen, if you can't hear me, just raise your hand. So I'm very excited to be here, first of all, because it's my first FOSDEM. And it was really very cool to see many interesting tools out there, many interesting talks. And I'm also excited to present you this new community project, which is called Collective Knowledge. And it's, I think it's a bit an alternative view from a researcher perspective. So we have all those cool tools out there, but as a researcher, I want to kind of use them, and I'll tell you what are the possible problems and solutions to do it. And in the past year, I was very glad that we worked with some great companies, universities, and nonprofits, and they provided lots of feedback. We were helping them to use CK, and they were providing some interesting, they were doing some cool things like performance regression testing, crowdsourcing experiments, and even automatically generating reproducible articles. So I'll mention this. And again, in the last year, while working with those organizations, we actually validated our approach that it works with most of the tools out there. So it makes me quite happy. But what is it all about? So in my past life, I was a researcher, and I was working on machine learning systems and compilers. And basically, when you have some interesting ideas and you want to implement it, so I'm trying to look at different papers being published there. And last few years, there were about thousands of papers being published on machine learning. And actually, someone told me when I had those slides that, in fact, last year someone mentioned there were 10,000 papers being published just on machine learning, if you count reports, blogs, and so on, 10,000. So as a researcher, I want to validate them, and most of them actually didn't share code and data. So what do I do? So, okay, when I was young, I thought like, okay, I'll start looking at some of the papers. I will learn great tools which you are doing, which you are working on. And I look at all the different tools out there, which are really helping you to simplify your life. I continue learning them. I become old, I have white hair now. And at the end, I managed to implement my idea. And when I implement my idea, I suddenly realize, oh, TensorFlow API changed. My new CUDA doesn't support my new GCC, which is out there. So what do? I start learning again, or I just quit, I get depressed. Or some people like Kenneth try to create some cool tools like EasyBuild, which is great. So, but it's, I think, a minority. So we know all those problems. And so I hit them 10, 15 years ago, but last 5 years, everyone is speaking about it. So one of the ideas is about, like every buzzword, let's do reproducible research. Fantastic. How do we do it? 5 years ago, we started introducing what we call artifact evaluation at many different conferences. And the idea was that when you publish a paper, you can voluntarily submit your code and data to some committee, and we'll try to validate your results. And it worked out very well. From the first conference, which we did like about 5 years ago on PPOP, we got 5 artifacts out of 25 papers, which was still like a little, but it worked. We tested methodology and so on. Last year, we got about 70% of papers at PPOP are submitting code and data, validate them, and it's a good thing. Now, what is bad? So when we started looking at it, of course, there is still no methodology about how you share and reproduce all those complex experiments, performance evaluation, and so on. It's really still in infancy. And what is really ugly, that over the past 5 years, I looked about 100 artifacts in all those 100 papers in top conferences, and they all have 100 ad hoc scripts to do some experiments, to download some models, to hardwire your path. If you want to change your path, you need to find the script somewhere, fix it, and so on. And it's really, so all our evaluators, we spend more time actually on trying to figure out how to deal with all those scripts than actually doing fun stuff, evaluating your result and validating it. And at the same time, even though you have all those code and data shared, when your lead researcher is leading, or your student or whatever developer is leading, all this, no one is using all this code and data. So it's really like, for me, I'm really it's a shame that it happens, because there is so much interesting stuff out there. And of course, the latest thing is like, oh, okay, so let's use containers. And these are fantastic tools as a kind of end solution, as a snapshot. But again, they're hiding the mess underneath. Someone still have to solve this mess. So it's not solved at all. However, this experience with all those conferences, when I was looking at all those artifacts, I started realizing that all those hundreds of artifacts, they do the same things all the time. And they're simple things. So if you look like, what do you usually do? As a high-level like algorithm writer, I would say that I have my program, image classification. I want to compile and run it. with some, I don't know, I would look at some different images out there. I would want to kind of adapt to my software, and usually I would try to detect that I have some GCC or LLVM Intel compilers available. I would try to find somewhere a data set, usually again with some hardware pass and so on, but it's still the same. And then I would run experiment, collect performance stats, produce some graphs, validate them, and create your paper. And this, all of them are doing the same. So what is happening? So this started like when I discussed it with all our colleagues, I was thinking that we're missing APIs, common APIs for all those tasks. That's all. Can we come up with some simple APIs which will automate all those tedious tasks which we have so that everyone will reuse those APIs? And they must be simple. And what is very important, and also you can provide some meta information, meta description for all those components which are out there so that everyone could use them. And the big point for this is that now if we have APIs and those meta descriptions in some common format, we can enable DevOps, because this is like why DevOps are not there in research, because you don't have APIs. How would you connect your Jenkins or whatever Travis with all these scripts out there? And that's how collective knowledge came into place. So we started, let's create just a tiny Python library which would provide you those human-readable modules, Python modules with human-readable functions. And they will provide you an access, so this will be always like program module with function compile and run, and it will have dictionary or JSON input and always JSON and dictionary output, because it's very easy to extend them. And at the same time, all the data which you share, you would also have some kind of unified meta JSON. And what CK is just your command line front end to just call those modules. For now, that's all. And if you, like, I know that when I was talking to researchers, they're like, oh, but it's too simple, we don't like it, we want complexity. But being in the industry for a long time, I said, no, opposite, like the simpler it is, the better it is. And that's why we had many fights, but okay. And at the end now, when you have all those components, the more components you have, you can now start assembling all the experimental workflows from those components and do more and more complexity, do some fancy stuff. And again, I'll tell you later some more fun stuff that we're doing with that. And at the same time, when we were discussing with our colleagues, we said that, okay, let's now, when you share like your code and data through GitHub, let's just have some common format, and usually it's just very high-level information. So whenever you see this collective knowledge compatible badge on some GitHub repository, around 100 now, they have common information. So first directory usually tells you your module, Python module API, so that you know that your further data is abstracted by this API. And then second level directories, you have basically what we call CK entries. This is your data, which can be anything. From your soft, in your soft abstractions, you would describe how you detect some software. In your program, you would describe what are your dependencies and so on. Again, very high level. Later, if you're interested, you can look at all the information on the website, but just trying to give you a very high level idea about what we did. However, of course, it's not a magic, so someone still needs to implement all those APIs, and this is kind of was a tedious task. So in 2017, we got some first adopters, so it was ARM and General Motors. And ARM, of course, they develop all those, like lots of hardware, different algorithms. They need to provide big performance regressions with testing. They have multiple workgroups working together. So I was thinking that maybe they can connect all their workgroups with the same framework. And the same for General Motors. So we started gradually adding those APIs ourselves or with our colleagues. And just again, what were the four first APIs which we provided? Very simple again. First of all, what do you want to have? You want to describe your operating system. How you, like, I don't know, like compile some program, what are your, how you can find some data there and so on. And this can be between different operating systems. So it can be Linux, macOS, Windows. ARM was contributing lots of stuff for Android. Then the same thing what we always do, detecting platform information. Again, notice that our API, afterwards they call different tools out there which you develop, but we're just providing a common API so that everyone else is protected from the changes in the system. The same installing, whenever you have, we want to adapt to your native environment. So we provided many APIs and many kind of what we call plugins for detecting software. There are around 500 software detection plugins. So basically you can just say CK search soft with either LLVM, dataset, and so on. It will find you all the installations out there. And the same for packages. There are great tools out there, EasyBuild, Spec, and some other ones. So we provided an API for those kind of tools so that anyone can share their even more high-level recipes about which tool you want to use and what are the dependencies. So if your software is missing, you can automatically call and install missing package through the tools available out there. And just the last thing about those, like very high-level thing about this CK, because it still probably looks like magic. So 20 years ago, I was working on performance auto-tuning, and basically last year, I was talking with my colleagues from Raspberry Pi Foundation, with Eben Apatan, and I was saying, why not to like kind of convert and create a program workflow which would do performance regression testing on different GCC versions on Raspberry Pi devices. And we created this workflow, which basically was a work which I did 15 years ago in my PhD. We did it in about a month. And then we ran experiments. We crowdsourced experiments. So the same workflow, now different users from Raspberry Pis, they were running the experiments on their machines, and they were collecting data on our Synology.org server. And suddenly, like I think 1 week, I collected so much data, which I think I didn't collect in 5 years of my PhD, which on one hand was kind of a good experience last year. On the other hand, I was crying that I spent 5 years on my PhD, like just collecting this data, and I could do it in 5 months. So, and now I can do it in 10 minutes because I see that someone is telling you that I have 10 minutes. That's fine. Okay. And the cool thing that we created, if you look on the website, with Raspberry Pi Foundation, we created an interactive report which is automatically generated also through CK. And if you look at here, you will see all this, what we did. It generates PDFs with all the papers, with all the graphs out there. And I just want to go down somewhere. So here, in fact, you will see all the way how we reproduce experiments. You can do it yourself if you look through this paper. But what is fun now is that because we have APIs, now we can actually embed some underneath this interactive graph. We can embed some interactive graphs, which if you click on it in your paper, you now go, I don't know, some cool point. This is like performance tuning. You will get to the repository and you will see different information, where this experiment ran, what was your performance. You can view all the compiler flags which were there. You can replay it on your machine because it's again all down for replay, and different work groups can do it. And now just I have still 8 minutes, 10 minutes. I wanted to show you a small demo just to show you that you can do it yourself now with a few clicks. You can actually start participating in this crowd tuning and from your machine, from any machine. Maybe there will be some bug or something, but let me check if it will work. I usually don't like to do live demos because they don't often work. Can you see the font? Everyone is okay? No? Too small? It's too small. So now I'm losing time to get this, but okay. Yeah, it's better. So now I'm on one of our remote servers where we actually perform some regression testing, performance regression testing. And we share those CK repositories. And again, what I do is that you would see many CK repositories out there, which are usually GitHub repositories, which you pull on different work groups or communities work in parallel on those. It's a distributed system. They work in parallel. And what I will do now is, so I have many programs here, many data sets here. CK list. What I will do now is that, what if I do the following? So all the repositories on the CK, big CK directory. What if I'll do the following? What if you do this at your website or for your user in the HPC center? What they will tell you if I would remove all your repositories? And I'm doing it now. And I hope that people will not fire me now if they're using this website or this server, because now usually they're reusing my server. So I have, I think, 1 minute to kind of restore it. So now when I do CKLS program, I don't have anything anymore. I don't even have this module. So what do? So I start saying that, okay, let's pull the repository with crowd tuning. And it should normally go to the GitHub, where we shared. And it starts also pulling all the sub-repositories, all those APIs, different APIs out there, automatically to rebuild you the workflow to do this interactive paper or this experiment on performance tuning. So I still have like 30 seconds, I think, to restore it. And I'm checking if my phone is no one is ringing me, but not yet. So, and I don't, well, so now I have this CK repository. So now again, let's check. So I have CK program, and now what is interesting that I can just compile any program out there. It's using Connor's automatic benchmark, and what it happens is that it starts detecting all the dependencies out there. I don't have time to show you how it looks. You can go on GitHub and you will see all the meta information about those programs. But now I'm going through plugins to detect all the dependencies. It needs compiler. So we detected some Intel compiler. We go through GCC. Still have 10 seconds. So let's install, I don't know, like some GCC. And each time it interactively tells you what is available on your system. So we're adapting to your system. Clang. Okay, it found. So now it detected all the dependencies. It tells you how do you want to compile a program. Let's compile with GCC Compiler. We compile it. We run the program, the same program. The first time, because I delete everything, I need to tell that my platform is Linux. It can be done automatically. It's not important. And now I'm running corner detection of some images. Notice that all those images, this again, I pulled, someone else pulled a new repository, and I'll have like hundreds of those images from someone else. I don't need to substitute all the paths. CK automatically finds all this for you. I run the program, I run it 10 times. I perform some statistical analysis, and this normally works for 10 seconds. Yeah. I provide some performance information. Notice that when you use Python to call CK, you will have actually a huge JSON file internally with provenance. And now just to start participating in this performance regression, I just do CK crowd tune program. And it asks you all different plugins what you can tune. You can tune models, you can tune compiler flags, you can tune whatever you want. Just to last a few things. And now it starts tuning your program and sending results to our server back. So in fact, this reproducible article, actually in a few days I can even get more results, and this will be a live article because I will be getting your results. I can apply machine learning and so on, something what I was craving for 15 years ago. Okay, I'll stop this. So just the idea is to tell you that first of all, I rebuild all this workflow. Now everyone still has access to all those repositories and it works. So it's very quick. Imagine now if I delete all my stuff and then it takes everyone like huge amount of time to restore. I saw some PhD students who actually quitted PhD because there was like server died and they couldn't reproduce the restore stuff, backup was not there and so on. So now it's very easy to reproduce stuff. And just going back to, I have 5 minutes. I just wanted to tell you a few things actually of our companies and universities, how we use them, how we now use CK. Just again, to give you an idea what may be useful for you. I think it's switched, sorry. Yeah. So I started, last year I went to Seattle and I was talking to my colleagues in Microsoft and the University of Washington, and we said, oh wow, but this cool stuff that now you have all those shared components, we can actually enable open science. It's again a buzzword, but what do we mean? Now instead of even publishing your paper, validating it and then like accepting it, why not to tell people that you share your CK workflow for a given task. We'll be validating it. We'll have a live scoreboard. We'll be, I don't know if you claim that you have performance analysis. We'll check it, and then we'll accept the paper. And with those guys, with Washington, Cornell, a few other universities, Cambridge, we created this tournament last year, Task Plus, and we said we took a very simple task for image classification. Everyone knows it, and we said anyone can submit any solution for image classification. It can be software, hardware, model. And just show us what will be your performance, throughput, accuracy, and we'll put it on scoreboard and we'll accept you depending on the results. And this was a quite a good success because so we got very diverse artifacts. We had some cool stuff. We had submissions with someone who was providing a cluster of 10 Raspberry Pi devices and showing that they can do the same speed of image classification as Tegra and TX. machines, so it was really cool. On the other side, we had some submissions from Intel provided a submission on using some powerful Intel server in AWS and Amazon Cloud. And just one month before, they published a paper claiming that they got a record number of record throughput, like 450 images per second on this server. And it was 50x speed up over traditional confe framework which they use. And we validated it. So we plotted all these graphs. So again, you can go there and you will see in this link all this live data from this tournament. And what is interesting, that this result from Intel, we validated it, but it was not easy. So when we started looking at the code and data we shared, it wasn't with CK. So we started validating it. We are not getting 450 FPS. We are getting like 50. And this is how when you read the paper and you don't know all the data, that's what happens to you. And then you say, no, I don't trust those guys. They're cheating. It's really not nice. But then because it was validation, started testing it. Library was missing. They used very specific Intel library with DNN and MKL, which you had to use it. We got it. We got like 200 FPS. Well, it's already better, but still not 450. We continued digging in, and then realized, and by the way, those guys were extremely supportive and were working together to kind of fix the problem. And then we found the bug that they had this model where it was supposed to be int 8. It wasn't int 8, it was still P32, so we fixed it. And then we got 450 FPS. We fixed the workflow, we fixed all the dependencies, we shared this. So in ACM digital library, you have a paper with those artifacts. And what is even cooler that 1 month later, Amazon colleagues called us and said, wow, we saw this workflow. And actually in 2 minutes we validated in our Amazon cloud and it worked. And it actually gave us the results. Furthermore, we ran it another workflow. We had FPGA submission on FPGA and it also worked. And we had a common presentation a few months ago. You can see the details where it's kind of, now when you publish paper, it's very quick to reproduce results on a native environment. You can use Docker, it's fine, but you can now actually use it with different systems, and it can adapt to your environment. In just 2 more minutes, I'm just finishing going through quickly. General Motors, what they say, they work on self-driving cars. So they said, they usually have to find the good solution. It's again public information, you can see it on YouTube. So I'm not saying any secrets. So like any other self-driving car, they need to find the best solution for model, software, and hardware, which would be, let's say, less than $100. You can't use like $1,000 chip in your car because it will be too expensive. It has to budget on, I don't know, 10 watts of energy. It has to be accurate so that you don't kill a pedestrian because there were set cases like this, as you know. So this is all like very complex task. So they say, but now we can actually use those workflows and we can run on different software and hardware. And we can find on the Pareto the best solution. So this again, this helps them. I'm a reproducibility vice chair for supercomputing. We're trying to see if we can automate different submissions, and we were doing this proof of concept SASOL application. You can look at it, how automated and how we can run it on different supercomputers. And okay, I'm finishing last thing because time is up and I have 1 minute. As I said, we also did quantum competition, quantum tournaments just 1 week ago in Paris, and there was good turn up, and you can see if you are dev room at quantum computing. We're actually reproducing work with IBM Rigetti, and we're reproducing some of the results, and we had some interesting new submissions about improving machine learning techniques, so you can see it online. Time is up. I have last slide. So now you can say, okay, it's all magic, it's all solved. Not at all. And it's like only at the very, very, very beginning of this journey to tell people that we can do reproducible research. And I think that CK is just probably the first prototype, I consider it still a prototype, which allowed us to connect all those different tools together, what you are building, and allow researchers to actually take advantage of them without spending the time of understanding what you're doing. So providing this like CK API with your tool, and hopefully you can plug it in. But there is a lot to be done, and we're open to collaboration because we're looking at standardization now of APIs, we're improving like installation, GUIs, and so on, providing more APIs. With that, again, I said I'm open to collaboration, contact me, and thank you for your attention. I hope it will be useful. I'm sorry that I was speaking fast because I was like, and we have even time for questions. I actually got at 10:40, which is like exact time. Oh, yes, sure.
So that's fine. Okay, one of the questions we can make, please.
Did you consider integrating with Luigi for the workflow scheduling so that you can use the workflow during development? You then have a tree-like workflow and you change a small thing that you can only run the relevant part and not need to run the entire workflow.
Okay, so the framework you call Luigi, I don't know this framework, unfortunately. So the question was if we considered using tool Luigi, right? Again, I will look at it, and which apparently can help you if you change small parts. It can help you trace it and so on. So no, we didn't. So far, what we do is when someone changes something, since it's a common workflow, someone else complains and saying we had a case when we broke something and ARM told us like in a day, like, oh my God, there is something broken. So it's an open project, distributed project. So there can be tools like this which we think can help make it more stable now. So I will look at it, thank you, but I don't know this tool yet. One more question, probably there is one more question, I don't know, yeah? Please.
You got some experience of moving some of these workflows into the production system?
Oh, they are used in production now. So yeah, so, oh yeah, do we have any, oops, sorry, I'm falling down. Do we have any experience using those workflows in production? So they use in production. So, and as I said, so, I don't know if I can officially start saying which companies are using it. I will prefer not to for now, even though you saw some of the which are kind of using. Yeah, we're using it all the time in production. Actually, why you didn't hear about this framework for the last few years, because I was actually working a lot with companies, trying to understand what they need, and they're using it. And now we're kind of making it like public. So, but yeah, absolutely. It's my main thing is we're working with companies. Okay? So thank you very much.